Hello, hello. Anybody home? How's everybody doing tonight? I have had my butt kicked today by DWC customer calls and stuff, so I'm way behind on everything. So we're starting at 8:30 tonight. Um, so hopefully y'all get the notifications on Facebook exclusive members group and on the Facebook community page, and we'll start seeing you pop in here in just a moment. But yeah, uh, customer calls, and it's our holiday season. So right now, whew, man, it's getting busy. Everybody's getting busy carving, making them Christmas presents and Thanksgiving presents and stuff. So uh, hopefully you can hear me. Hey, Kurt, how you doing, buddy? Good to see you. I am running behind today. I've been oh man. Uh, was that busier than busy? It's just busy. It's been an insane day. But nevertheless, we're going to have a day today. I wanted to be out in the shop. I did get some stuff done in the shop. We'll talk about that. We're going to see about doing a special class for the members only. Just kind of we'll see what everybody thinks about maybe like Sunday afternoon or something after church and all. If anybody wants to pop in to a live stream when I'm out in the shop we talked about me being out there and making the deco box, the little box, that's good for all occasions. And especially some of them wanted to talk about the jig, and stuff and everything. And I got the parts are still two-sided taped on the CNC. I've got the lid piece, the bottom piece carved, just not cut out. I've got the feet strips, the strips that make the frame around the feet, and then the handle and the two parts. I've got those ready to be profile cut. I got them wood milled down, and I got the jig board on the table, but nothing cut out or nothing made with the jig yet. And I don't have the cove sides made yet. I got it glue up. I didn't have an inch and 3/8 piece, so I had to glue together some 3/4 to make an inch and a half, and then we'll mill it down and all that stuff. So I want to be able to have hey, Chuck, how's it going? I wanted to be able to have a special class, members class, kind of like maybe like Sunday afternoon out in the shop, kind of a casual thing, and talk about the jig, because I know there was a couple of people that wanted to, ask about the jig that I talked about. Remember the jig that we talked about that holds the parts kind of upright so the CNC can cut those parts and everything. The little tenon, take the shoulders off the little tenon, and then cut the groove right down the middle that the piece gets into. So I got the jig. Everything is two-sided tape down on the CNC. Some of the parts are milled, didn't get everything done. And then I was doing that between calls and everything. And so I'm ready for like a little casual little class, or members thing. And we'll see about Sunday when everybody gets in, if everybody pops in and stuff. So Sandusky, how's it doing? Chuck Fleming, good to see you. Chuck is Chuck, welcome. Good to see you. And it's thank you for joining and all that wonderful stuff. There is a class. Sorry, Chuck, I'm running a little bit late tonight. DWC customers had me busy today, and then I was, in between trying to get the things out in the shop ready, but I didn't get that done. So we're going to have a little Q&A tonight. We're going to do a discussion, and then we'll talk about maybe a special class or something. Like if anybody's interested, we can either try for, I don't know, Monday or Sunday afternoon. I thought like a little casual day, just out in the shop and, having a conversation, not for a long period or anything, but just to talk about the jig and the setup and stuff. This is not made yet, but it's right there on the table, ready to be made. And so I appreciate you for joining the exclusive members. Thanks, Chuck. And I saw your email asking about a class, and yes, there's a class tonight. We're just I'm running 30 minutes behind. It's going to be 8 o'clock on Thursdays, Chuck, for the private members, and 8 o'clock on Fridays for the public. I'm just running behind right now. It's 8:30. and all that wonderful stuff. What I'd like, Chuck, and this might be a good class for you to really jump in on, because it is a Q&A, and you're, just getting, if I'm not mistaken, you're kind of just now you're like, hey, I'm to make sure make sure if I understand the story correct, but you're kind of you're retiring, and now you're like able to focus some more attention on carving and stuff like that. If that's true, I don't know if that's true or not. I think that's what I just think in my head. But so, tonight is a kind of a show and tell, you ask, I answer kind of thing, and everybody can participate. And we'll be in the Vectric software. So it could be a Vectric question. It could be a Planet CNC question. Not everybody in the members have Planet CNC. They have different CNCs and all. It's not all just digital wood carver here, but it's going to be a Q&A. And the Q&A is always good. Yep, absolutely. And then, yeah, David. And then David, if you're just popping in and all that stuff, if you heard, I want to, when everybody kind of gets in, I want to talk about, if y'all remember the little deco box we talked about last week, I got the parts and stuff, two-sided taped on the CNC. I've got the bottom and top done, carved and ready to cut out. So they're ready. The feet part, I got the board milled down. They're ready to cut out. I got the Cove board glued up. I didn't have an 1.5 inch board to make 1 3/8, so I had to glue up 2 pieces, but it's all glued up, ready to go. And then I got the jig secured down, but not made. None of the pockets, none of the angled little pockets we talked about. So I want to be able to I got a pretty good start, but I didn't, there was no way with trying to do it between calls. I couldn't get it done. And I struggled with it, but, so I want to have like a special members kind of get together or something, maybe Sunday. I don't know, but we'll figure out it. I want to maybe send like a little casual thing, where it's not, so formal or anything like that. I mean, it's always casual with me, right? But where we're just out in the shop, and we might run a part or two here. We're not going to do any big long carving where you're sitting there listening to us and staring at a CNC for hours, kind of thing. Not that. Just a Q&A, because by the time that class comes, I'll have the jig kind of made ready to stick the parts into, so you can see how it works and all. All right, let me see here. Let's go with a question. And here's a great example, guys and girls. I'm going to throw it, Kurt, I'm throwing you on the screen here. But if you have a question, put a couple of question marks or a single question mark or whatever in front of your question. So that way I know it's a question for me and not for someone else in the group and all that stuff, so that we can answer them. And Kurt's question is could you go over using the zero plane in regards to two-sided machining? Becky did her magic key and used the zero plane for toolpath purposes to get the rounded shape. Got kind of confused. Okay, so let's go over to the computer screen. Let me share an entire screen. And let's switch that around. Put me down here. All right. So let me go back into this job right here, and let's go to the job setup. Let's do a 9 1/4, like a 1x10, 9 1/4 board. We'll just go 12 inches, 1.5 inches thick. It's going to be a two-sided, double-sided job. We'll touch off on the material surface for each side, and we'll start in the bottom left corner, and I'll flip it. I like flipping my board to and from instead of versus side to side, but it really doesn't matter, that kind of thing. And we'll click OK. So now Becky loves, and I really like it too, the asymmetrical alignment pins, positions and everything when you're doing two-sided jobs for easy alignment. And asymmetrical means like, typically it's like a 1/4 inch dowel pin and wooden, dowel pin and everything. And asymmetrical means you just kind of randomly place your holes. It could be 2 holes. She likes using 3 holes, that kind of thing, because it's only one way the board can fit on there. When it's flipped, when these are mirrored, there's only one way it can go. It can't go any other way. So asymmetrical. She likes those type of alignment pinholes, and they're great. You know, I love it for two-sided jobs. But that's not the question that Kurt's asking. Kurt's asking the question about a two-sided project where there is a zero plane. Now, let me see in my arsenal of models. Let me see in my arsenal of models if I have a two-sided model that that could be or we might have to make up one, but I want to be able to import it so you can see really the zero plane. So give me 2 seconds here. The top piece. Just bear with me just a second. I'm trying to find a knife handle, knife support, tool setter. Come on, dude. Come on. Sabo. US flag. All right, give me a second. .stl. Let me narrow my search. Okay, so we got Firebox. Okay, here's a good one. Let's open this one up. And it's a skateboard deck. Right? Okay, a skateboard deck. And so let's go to in the, I think everybody can see that now. Everybody can see that. Okay, so in, let's go to top view real quick. When we're just now importing this, right? So first off, this is coming in metric. It's 200 millimeters by 800 millimeters. So let's click on the button to scale it to inches. And it's about 32 by 8. So let's go back. Let's hit cancel for just a second. And let's go back to our job setup and let's set up a board that's, let's go maybe 33 by 8.5. Let's do that. So let's go back in here and I'm going to just lay the board along, let's say the x-axis. So we'll go 32, 33, and then we'll go, we should be able to go with the 9 1/4. And then for right now, I'll do the 1.5 inches. Everything else is going to stay the same. So let's click OK on that. Let's get rid of these circles really quickly. They don't belong. All right, let's do that one more time. Let's import skateboard deck. Okay. All right, so first things first, again, I'm going to scale metric to inches, and then I need to rotate this part 90 degrees. So I'm just going to go plus 90, and then I'm going to center that in. Now, this board is actually 2.167. I'll make the board thicker when I get when we get back set up and everything. I think the model will still import with everything. Nothing will get cut off. And then now here's the important part. Now that we have it positioned and everything, let's talk about this really quickly. And this has to do with the zero plane, and it also has to do with the limit plane too, which is kind of two different things. So let's come here, and man, I really want to. All right, let me make my board a little thicker. I really want to make my board thicker right now. So let's go 2.5, 2.5. Let's do that one more time. Import model, skateboard deck, rinse and repeat. Go into top view, rotate this 90 degrees, scale metric to inches, center model, rinse and repeat on those steps. And then let's turn this up to the front. Okay, now very important. So this red outline right here, this is my 2.5 inch, whatever I set it up, 2.5 inch board, 2.5 inch board. And half of it, right? 1 1/4. That's the center mark. That's the zero plane technically for side 1. At the 1.5 inch mark, the zero plane is like if I turn off the side 2 view, you're only going to see the top half. And then the zero plane is at the bottom of the model, right? And so in this case, the zero plane is right in the middle. And so if I go to the next screen here, you'll see this black line right there. Now that represents the zero plane. So everything above the black line is side 1. Everything below the black line is side 2. However, that's not true in this case, because if you notice, I got to be able to get to the bottom side of that skateboard to do carving and all, but it's kind of above this. It's on side 1. So when this board's flipped over, if I don't have my limit plane and I don't allow the bit to go past the zero plane to that limit plane, which is the next level down, so I can carve that, it won't actually carve. So when it's flipped over like this, let's come over here. Oh, you booger. Flip that over like that. Bear with me. It's a little crooked, but you'll get it. That black line's right there. So when my bit's coming down, it would stop at the zero plane, because the zero plane, you can only carve on one half of the project at a time. On side 1, it's got to be flipped to side 2. And if the zero plane is there, the bit doesn't go past the zero plane. And that right now, that zero plane is in the middle. So we got to be able to go past it to be able to carve into, so we can get into that little pocket in there, all that, all that stuff right there. It's dark right now to see, but we got to be able to get past it. And especially down here, look at this guy. This guy is way, but there's the zero plane up there. This guy is way below the zero plane down here. The bit won't be allowed to go past that zero plane unless we give it a limit plane. And so let's actually bring the model in to make it make sense. Let's go here. So right now the model's centered right here. This is a very key important part right here. Create both sides, but the overcut distance. The overcut distance is saying, hey, how far can I go past the zero plane? If I don't put an overcut distance, then the toolpath and the software won't let me carve the parts that are below the zero plane. You see this? This is side 1 right here, but so is this down here. This is also side 1 right here, but it's below the zero plane. So if I don't put in an overcut distance, the bit stops and the project kind of stops right there on that line, that halfway mark, right? So here I wish I knew I wish you could take a tape measure and measure that distance and all, but I know that this is 1 1/4 inches and this is 1 1/4 inches. I need to be able to get just about to here. So we'll go like 3/4 beyond that. So the overcut distance, let's see here, 1 1/4 inches divided by 2 is 7/8. Is my math right, guys? 7/8, and 7/8 is 1 1/4 inches. Is that wrong? Or is it 5/8 and 5/8 is 1 1/4 inches? Off the top of my head, somebody in the chat, give me help, lend me a helping hand. Is it 5/8 plus 5/8 equals 1 1/4 inches, or is it 7/8 plus 7/8? I can do the math right here. Let's see here. 1.25 divided by 2 equals 5/8. All right, I got it. 5/8. So I have to now. 5/8 is the halfway mark, right? It's the halfway mark of this bottom half down here. So I need to be able to get a little bit further, most likely. I can't measure that, but I want to make sure I can get down to this part to carve that side. So I'm going to go ahead and say that I can cut my overcut distance will be because I also have to think about this side too. So halfway on side one right there, because the bit, when I'm flipped over, it's got to be able to cut past that line to this part, right? This part right here when it's flipped upside down. So I definitely, halfway is 5/8. I'd probably say, I want to be able to go 7/8. So 0.875 would be my overcut distance. And then when we import that, okay, it's very important. And I've never seen, and Kurt, you'll have to bear with me now because I haven't seen, I saw the thumbnail for Becky's key and everything, but I didn't see the actual video. I haven't watched the actual video yet. So I don't know if she, in her video, if she talked about if she had overcut requirements, overcut distance and limit planes and all. But the zero plane is that center plane right here. And it's very important that she might have, because I from the picture, the key has a, I don't know if it's a heart or it's an opening. I don't know what the shape is, but there's an opening at the top of the key all the way through, and it's rounded like on both sides. And to be able to kind of round and everything, that zero plane is kind of right in the middle, but without it, it's a hole. And so the bit would want to just plunge right. It would want to, come over and just plunge straight down. So she probably turned on the zero plane and made it part of the carving. So that way there was a surface. So when it came over and rounded over, it stopped, would come across that zero plane and then up and around the other key and everything. So without it, it's just a hole, right? The bit just wants to plunge, to wherever, the bottom of the whole thick board. But the zero plane being in the middle, if that's active and everything, now there's a surface there. It's technically a surface. So it can round over, come down, across, and then up and over the other ring and all. There's a surface there in the middle. Do you understand? But now let me show you here. This is very important. Okay. Here on this project right here, you'll notice that it looks weird. It doesn't look like a skateboard deck. It looks like it's fully solid filled in here, right? Looks like it's fully solid filled in here. And that's because I have double-sided view turned off. So right now it kind of just fills in. Look at it, fills all that whole thing in with wood, so it looks like a big old chunk of wood. And that's not true. That's not what it looks like, on the skateboard and everything. So when I turn on double-sided view, you see that would go away. Now we can actually see, side 2 and everything. Okay, side 2. So now this, let me get straightened back out here, and let me I'm going to tilt it just a little bit. Very faintly, if I zoom out, you might be able to see the corners here, but very faintly, you can see there's like a little bit of an invisible plane right here. Okay. And that is the zero plane. That's the plane that runs right down the middle. Now, notice here on the zero plane that parts of the skateboard on side 1 are below the zero plane. They're down here. The zero plane's way up here. So if I were, carving and everything, and I didn't have that overcut distance, the bit wouldn't be permitted to go past this level here. So it would kind of ride here, and then it would come straight across, the bit milling, it would ride here and come straight across and ride here and come straight across, milling. It wouldn't go down here. The zero plane would stop it. But the overcut distance allowed the bit to be able to go past the zero plane to, in my case, it's only allowed 7/8, right? 7/8 down. And so if I turn off this, you'll be able to see kind of, this plane right here and everything with two-sided view turned off. This kind of this little level right here gets treated not like the overcut distance. It gets treated like the zero plane, like there's no side 2 when we turn off side 2 visibility. But you're still like, well, wait a minute. If that's the zero plane, what's this up here? Okay, so this is the bottom plane of the board because there's no side 2 technically right now because I got it turned off. This is still down the center of the board. That's the 0 plane. Let me turn that back on so I don't confuse you. But this is the 0 plane right here. And again, like I said, if it was carving and everything, it would, if there was no limit plane, it would be limited to that halfway mark, right? And the same thing when I flip sides, this would come here and it would just come straight across the plane and come up and straight across the plane and come up and all. But now I have an overcut distance, so it's allowed to go past the line, past that plane, not line, past the plane by 7/8 of an inch. And so what Becky most likely did was that, and you can change the location and the height of the 0 plane and all that stuff in the import and all that. But what Becky most likely did is because there's a hole there, that ring, there's nothing. There's this has something. If I go past the 0 plane, there's something right here. But on that key, there's nothing. So she probably lowered the 0 plane in a way that it would do the round over on the edges, but it wouldn't try to plunge down that hole and it would come across. So that way when she flipped the board, it would do the same thing on both sides and create that nice round. Are y'all following me? Do you understand that? Does that make sense? Do you understand that? And as far as the 0 plane location, that's the little slider bar, on the import window. You can change that location. There's a few ways. But if we look at our components here really quickly, the limit plane, that we brought in right here, okay, we're allowed to go 7/8 of an inch past that 0 plane. So you can kind of see it open up there, but you see how it hollows out right there. It's kind of weird, but you see how that 0 plane hollows out, so the bit can actually go down past it to carve this and everything. The limit plane is set to at 7/8, kind of thing. If I turn that off, there's no limit plane, so the bit would just kind of want to just come flatten out right there and everything. So now so that's limit plane, but the 0 plane, if we go back to undo import, wait for it, and we go back to import 3D model, and we bring in the skateboard deck again and click open, go to top view, rotate 90 degrees, scale metric to inches, center the model, and right here we go position and alignment on the front view here. Whoop. All right, so now here is where I can change the position to increase or lower the 0 plane. Now I don't have, now this skateboard I only have a 2.5 inch board or blank. My skateboard is 2.1 inches. I only got a little bit of room. So I don't have a whole lot of room to, I can bring that right down to here. I can bring that top part right up to there. Probably wouldn't do that, but I don't have a whole lot of wiggle room there, but I can change the position of where that 0 plane falls to achieve whatever my need is. And I'm not sure what Becky's exact need was, other than probably, like I said, so because there's a hole there in the middle of the key, when it's carving around, it's going to want to create a toolpath like plunge straight down, and the 0 plane will limit that. And I shouldn't use the word limit, but that's what it is. It's not a limit plane, but it'll, it kind of gives a surface for the bit can run over now. And Kurt, that's the best answer I kind of got for you right now, and without seeing the actual video and what her reasoning and all that stuff was for. Hopefully that was something. Hopefully that answered something, the question and all that stuff. Right. Cool. Okay. Good question. And let's see here. Let's go back to here. And the let's see if I lost someone. You're welcome. All right. So any other questions? Feel free definitely to throw in and ask. While we're waiting for that next question and everything, I want to kind of do a little bit of show and tell. Something that I'm super happy about that is coming soon. But I am big on making accessories for the CNC, and especially because and you know, like the Digital Woodcarver line is the company that I work with and everything, but some accessories in the future are going to be able to, you know, fit on other machines and stuff. Well, with the Digital Woodcarver CNCs, we just updated the user interface to a program. It's Planet CNC, but to the user interface to a design I've called OmniControl. And with OmniControl, it allows the user, if they have limit switches on their machine and they have a tool height setter, they could do something along the lines of semi-automatic tool change. So they don't physically have to have a rack. They don't have to have a tool changing spindle. They could have a router. They could have a spindle, whatever. But the machine, when it's carving, it would present itself to the user, the bit, and it would say, hey, take out this bit, put in the next bit and press OK when that operation is done. And then once they press OK, it would go back and it would measure itself on a tool height setter, and then it would continue the carve. And on that semi-automatic tool change, one of the key requirements is a tool height setter. And there's a lot of different tool height setters on the market. And if we go online, let's see here if I can pull another tab here. If we go online, and I believe I already have, yeah, I have right here. If I type in on Amazon, right, tool height setter, there is, and it's the electronic ones, not those manual ones here. So let's scroll down a little bit. Let's type in, let's CNC tool height setter. Let's do that. So on the, let's get past these. You know, typically on the tool height setters, you would see something along the lines of this, right? Electron tool height setter. But now that tool height setter is 2.5 inches tall. And some of our machines are only have a certain amount of travel, like our mini carver and all that. So it only has 4 inches of travel. So it needs a low profile option, right? And so when we're looking at, if we were looking at tool height setters, if I can get back there, the like low profile tool height setters, there's a few little options. And even at, at a good price too and everything. And let's see here. There's, with the buttons, there's button tool height setters, but there's also fixed tool height setters like this one here, right? And typically the fixed tool height setters, they don't mean they don't have a button. It's just like a little aluminum plate or brass plate or whatever the case may be. They typically come, in different sizes, a 1/2 inch, whatever the case may be. So that's a low profile. The only thing, there's a little bit of a downside with the fixed ones. Like the fixed ones are based off of continuity. So when my bit comes down and touches that plate, that aluminum plate and everything, I mean, there's got to be a continuity signal. Otherwise, it's not going to stop. It's going to want to drive through. So if I'm doing a carving and everything, and let's say I'm carving pines or pitch or resin and things like that and everything, and my bit is just getting gummed up, or, maybe I got a little zealous and I overheated my bit or something, and it's kind of hot and kind of blackened or whatever the case may be, I have now kind of covered my metal, if you will, my carbide and all that stuff. And so there's, it could block the continuity and everything. And so having a fixed sensor like that, that's the downside. It could just, there's no continuity, so it doesn't stop, that kind of thing, right? So a button is a trigger, right? So when it comes down, it triggers, and it triggers a sensor and everything. And so with that being said, now in the low profile, situation and everything, I am in the process of designing and getting ready to release to a market a tool height setter. And let's see if I can show it off a little bit. So here is, let's go here. So working on a new low profile tool height setter. These are just some pictures of the different sides. Let me open up another window. Which one was that? That was number 1. Let's go to number 2. So it's a button type. And so I'm working on that. And again, this is just the first module out, the first prototype. It is, it is currently right now 3D printed. Eventually, it's going to be injection molding, getting into injection molding and stuff after, but the 3D print, and it's a resin print. So I'll be, and this tool height setter can work with any machine. I can brand it for any machine in any company and all that stuff. But that's one of the things that's kind of what I work on in the background. I like R&D, and I like, designing and developing things. Mostly it's third-party accessories for the digital wood carver brand CNCs, but in this situation, this particular sensor could work with any CNC that might be, low profile. It doesn't have a whole lot of height, so it can't really use one of those tall buttons and all. And of course, open builds, not open builds, but Onefinity, they've got their, their low profile tool height setter for their machines that can work with other machines as well too, I'm sure. Shipoko, things like that, they have their tool setter that could probably work with other tools and all. But yeah, so I'm excited about that. That's kind of what's happening on my end with stuff that I'm working on and all. All right, let's see here. We got another question here. I just wanted to share that little tidbit with you. Thought that was fun. Okay, so we got Chuck says, if you're using a project that is online, are the settings for the cuttings typically set, or do you need to go into detail as to where you're doing with your skateboard and all that? Okay, so that's a great question. Here's my rule. All right, so if I go on Etsy, if I go on eBay, if I go on Thingiverse, TurboSquid, whatever, and I download a project, 3D model or just a project, could be a VCarve project, it could be anything, right? If I download an actual project from online that I open up, it might have a CRV file already, meaning a carve file. I can open it up in VCarve Pro, Desktop, Aspire. It might have a CRV 3D file, which means I can only open it up in Aspire, but I could open it up and it's already got tool paths and everything set up in there. Well, not all machines are built and created equal. Okay. So it's very important that you never take a tool path for granted. Yes, the tool path is there and it's, it's calculated for the vector that's in the design and all. That's great. But what you need to do is you need to open that tool path up for editing. You need to go into the tool and you need to select the comparable tool from your tool database. That your tool database most likely has tools set up for your machine's speeds and feeds and plunge rates and everything like that. This, you don't know who made the design, like, personally or anything like, you might, who knows, but you don't know. Like, they could be running on a machine that can run 1,000 inches a minute, while you're on a machine that can only run 225 inches a minute. And they have tool paths, doing full 3/4 inch cuts at 700 inches a minute. which would just blow your machine apart if you tried to carve at those speeds and feeds and everything because of its strength and rigidity and build and all that stuff, right? So while the toolpath is there and everything, those settings may not be ideal for your machine and your setup and your situation. So you can still use the toolpath, but you need to edit the tool and select the tool from your tool database, a comparable tool, quarter-inch bit kind of thing, V-bit, 90 degree and all that stuff. But you need to put your tool in that has your settings and everything and recalculate that tool path. So it recalculates with your tool and that tool's settings for your machine, right? So that's really, as far as that's really all you need to do. If it's got the tool paths and all that, and you've got the full design, hey, awesome, right? Totally cool. But you just need to choose the tools from your tool database so it runs on your machine. Now, if it's a design that has nothing, it's just a model, an STL you bought off of Etsy or whatever the case may be, you import it in, and it could be a vector too. It doesn't have to be a model, but you import it in, you size and lay it out for your project size that you're doing and all, and then you have to go over and make the tool paths, whether it's a V-carve tool path or a pocket cut or a profile cut and everything. And I will say this, I would probably say a good, let's go 75% of the projects that aren't models, that are V-carve type projects, that you can go on Etsy and buy, like a little deer scene and all, they're V-carve. 75% good chance that it's a V-carve project. Now, there's other chances where, you would run a pocket cut or maybe a profile cut to cut out the shape, or it could be a 3D model where you do a 3D rough and a 3D finish cut, that kind of thing. But when you bring that design in, you have to set up the tool path for what that job requires to get cut, to be cut. And that is a learned process, Chuck. So you're like, okay, if I bring in a model, how do I know what tool path to be used? Well, if I import that skateboard, let's go back to create a new file. I believe I was at 33, and I believe I was at 9.5 or something like that, 9.25, and then 2.5 inches. And I import that skateboard body in, import 3D model, skateboard deck, come over here and orientate it. I got it to get it to fit onto my board. And right now this thing is 800 inches by 203 inches. And that's technically what it's reading. The software's reading it, but it's designed in millimeters, 800 millimeters by 203. But I need to scale the millimeters down to inches, or 2 inches, not down to, but to inches, and then center it. And then make sure I'm centered here. I would want to create both sides, but I didn't set this job up as a two-sided job. So bear with me on this. So it's just a one-sided job. And notice there's no two sides, right? Notice how it cut it off and everything, right? So anyway, ignore that because I didn't set the job up as a two-sided job. But this is a model. And there's a 99% chance that with a model, you're going to do a 3D rough and a 3D finish, 2 tool paths. You might have a profile cut in there to cut out the profile, to cut it out once both sides are carved, once the 3D finish is done and all that stuff. But typically for models, unless there's some kind of like I could V-carve on this and I could carve, skate or die, on the bottom or something or whatever, the whatever the case be. So I could V-carve in there. So now there's a V-carve tool path. But this, if I was just doing the skateboard body, it would be imported in on a two-sided job setup, set up both sides, and then I would just set up a rough cut and a finish cut. Rough cut hogs away my waste material. Finish cut does all the nice detail work. That's the only 2 tool paths I need to use with the model. And then once that's done, I got to cut it out. I got to cut out the whole, profile so I can, it's not still in a square board. So a profile cut. So that's the 3 tool paths that I would use with this project. And that's literally kind of, how it is with most models. You have 3D rough, 3D finish, and a profile cutout. And the only additional tool paths would be, do you want to carve some text on something, or do you want to engrave a little cool design or something like that on it, whatever the situation is. But you never take a tool path for granted. You always, even if it's there, you still recalculate with your tools and you'll be golden. Okay. But the learned process is, hey, over time, Chuck, you'll know that when I bring a model in, I've got basically kind of pretty much those 3 tool paths, unless there's something else I'm adding to it. If I'm bringing a V-carve sign in, it's going to be a V-carve and then whatever, cut. And you'll start to learn what tool path achieves the goal that you're trying to achieve. What tool path is going to get it done. Is it a pocket cut that gets it done? Is it a profile? Is it a drilling operation? What gets that job done? And that'll just come in time and stuff. And in the meantime, you're a Digital Woodcarver customer, so you have 24-hour support, not just for your machine and stuff like that, but you can literally, you can text, you can call, you can email, you can Facebook Messenger, and you can ask questions to get pointed in the right direction, with whatever obstacle you're facing. So that's kind of a great little asset. I don't know if asset's the right word, resource, so that like as you are kind of getting reorientated to this stuff in CNC, and not just reorientated, but just orientated as well, you can pick up the phone and say, hey, I'm doing this, and I've never made one of these before. What process am I going to do, or whatever the case may be, or what bit am I going to use? And I can look at your design with you and help answer those questions if you ever need. Yes. So this is a very key thing right here. Being a rookie, I'll need to start with easier side of projects and stay away from the models till I'm, further along in the curve. That's fine. Absolutely. And I always say, crawl before you run, especially crawl before you sprint. And some models are a sprint. Heck, some projects, some just V-carves and stuff are a sprint. Like, a crawl type thing is if I was making a house sign or a welcome sign or, Merry Christmas or something. But if I was doing a V-carve inlay that was deep, where I needed to use a ball nose end mill, that's a little bit, you're kind of, you're past the fast paced walk, and now you're in a little bit of a jog, you know what I mean? So, even the, a simple design that you want to inlay on a board could be complex depending on the setup and all that stuff, but it just comes with time. So that learning curve, and once the more you do of the little things or the big things, whatever, the more and don't be afraid to try or experiment. Or if there's something like, oh, I really want to do this today, or I really want to do this before Thanksgiving, or I really want to do that, but I'm not far enough along, you can always ask for help. And you have a helpline that you can reach out to. And if you're a member of the Digital Woodcarver Owners Group on Facebook, you definitely have a helpline. You can just ask in that group, hey, I want to do this. Can anybody give me any pointers or tips on, that? And the group will jump in and answer question as well too. All right, so hopefully, Chuck, that answered your questions. All right. Good conversation. What do I got here? So awesome. All right. If any other questions pop up, let me know for sure. Now, what I want to, while we're talking everything, the deco box, okay? And I'll pull up the SketchUp design of it as a reminder from last week. That was this guy right here, right? And so I've got the, let me do an unhide. Unhide all. Am I still in a tool? What tool am I in? It's not letting me unhide anything. Oh, I got to go back into that. Let's try that again. Unhide all. There we go. There's always a reason why something doesn't work. and also you always got to kind of figure it out. But so I have the board. These are 1/4 inch parts. This thickness of this part and the 2 posts that hold it up, they're 1/4 inch thick. So I've got those the board milled down. I started off with a 3/4 board because I wanted a dark board, and I happened to find a board that had a nice little dark color. I'm still going to add some black to it, but it happened to be, it was small enough for what I needed, but it was 3/4 thick. So I had to run a pocketing toolpath and pocket a 1/2 inch of it away. And it was, I wasn't wasting a whole lot of wood. It was just a small piece, but I'm ready to cut those parts out. It's just a profile cut to cut those 3 parts out. And these parts right here, the 4 framed parts that make up the miter. I've got the top, which is this piece right there, the tan piece. And I got the bottom ready to cut out. And the only thing I did the glue up on the side walls, I just haven't made that cove cut to, you know, cut and miter those. So I'd like to, I got those, they're still on the CNC. They're still ready to, you know, finish all the cuts and stuff. But I'd like to, that was what tonight was going to be, you know, us being out in the shop and, you know, doing the jig and all that stuff. And if you recall, the jig is the, let me hide this. It is going to be holding these 2 parts. That's all it is, those 2 parts. But I would, if I was doing a batch, I'd be doing a lot of those 2 parts, but it's going to be holding those 2 parts upright so that the end mill can come through and make this cut right here, right through there to open up that. And then on the bottom side, it's cutting, the piece gets flipped over and sit inside the jig, and the jig holds it upright, upside down, if you will, so that the bit can just come around and create those shoulder cuts and everything to create that little tenon, you know, and stuff. And so that jig is an interesting one because these pieces have a 15-degree angle right here, 15-degree angle. So the jig, the little slot that those parts slide into, also have a matching 15-degree angle. So the part literally goes right in and, you know, kind of almost locks into place. But there's 2 little pieces that go on the front side and the back side, kind of trapping it so it can't be like all teeter-tottery if it were, you know, kind of thing. So so it's an interesting little jig project, you know, and stuff. So I want to be able to show that and talk about it and stuff. And I'd like us to maybe see if, like a Sunday, I know Sunday's my day of rest. It's really my only day off during the week from Digital Woodcarver. And it's kind of a day for, you know, family and God. But if I'm just chilling out in the shop and got the camera running and able to talk to someone and just have a kind of a casual conversation and talk about the project and show it and make the cuts or whatever the case may be to kind of, you know, go through the process and stuff. I'm all for it, you know, in the afternoon after church and stuff. So anytime, you know, like maybe an early afternoon, not like an evening. And it could be an evening if somebody doesn't want to ruin their Sunday because they're out with their family and they may, hey, I'll be home Sunday night getting ready for work, Monday, that kind of thing or whatever, but not too late. I don't want to do late. I just want to be, you know, just kind of a casual thing. So if Sunday is a good day for y'all, let me know in the chat or in my email or something. If not, then we'll do it sometime this week coming. Monday, Tuesday, Wednesday. I'll put out a post somewhere. All right, let me know about Sunday and all that stuff because everything is kind of ready. It just, I got to do the cove cut and stuff. Now the cove cut, I'll film that so that during the live event we can play a quick little fast forwarded type of film to see the process of that rough cut and finish cut right on the cove cut. It'll be that because of the time frame that it takes to cut that, it's a long cut because it is a 3D model cut in a sense. I'll have that all done and ready, you know, while we're sitting there talking and stuff. Okay, but let me know. All right, ladies and gentlemen, we are an hour in. There's not a whole lot of members attending tonight, so there's a good little chunk of our group that are missing tonight, and it might be because of the Thursday night they're not available and all that, and understandable. But now's the time. If you have any questions on anything, I mean, fire away, and we'll see what we can answer. Now, just so you know, while I'm waiting for those questions to pop up on this jig, right? Let me make this sheet active so it's white so you can see it. On this jig, these are the boards that are kind of going to be in front of on each side of the part that kind of trap it in place. So let me move that out of the way for a minute, and let me move this one. Let me undo that real quickly. I accidentally had one of my things selected. Move that out of the way for a minute. So on these parts here, there's a 15-degree chamfer cut, and in the tool path, we have a chamfer cut that is using a 30-degree bit. Now, on the 30-degree bit, the 15-degree angle, I'm only cutting down 3/8 of an inch, 0.375, in everything. And so that cut is going to mill the 15-degree angles on the side. It's going to kind of like almost like going to pocket it out, if you will, all the way down to that 3/8, and that's going to create the part. And I think it'll show it in the 3D view. Why wouldn't it? In the preview. It's not an undercut, so it should show it. Maybe. Let me see if I start depth of 0, 30 degrees, 15-degree angle, no overcut. That's all right. There's the vectors. Did that preview not preview it? Preview. Let's try that again. Preview the visible toolpath. There we go. So in here, now there's a pocket cut too that goes with that. So let's preview that. It kind of opens up the middle, of course. Super strange that that is super strange that it's not showing the cut. Why you glitching on me there, boys and girls? There we go. So something that had to be recalculated. But so you can see when this part goes in, these are dog bone fillets or T-bone fillets. It's just a place for the router bit to escape when it, a place for it to come out. But on the pocket cut, so I have the part is going to slide right down in there, and the 15-degree side angle is going to trap that part. Think of it almost like a V-carve inlay with a 15-degree angle, and so the jig is going to hold that. But even though it's going down 3/8 and stuff, don't want there to be any kind of and it's a small part. I mean, the thing isn't even that big, but I don't want it to be any flex. So there's going to be two pieces that kind of trap it. So when that bit is cutting through, it holds it rigid and still. And so hey Chuck, have a great night, buddy. Kurt says, what bits did you use for the cove cuts? Well, I only used a 1/4 inch ball nose
with a 1/4 inch shank, 1/4 inch ball diameter, and then a 1/4 inch end mill. So the end mill did the rough cut. I could have went much bigger for sure. I had plenty of room. The board's 5.5 inches wide, 1 3/8 inch thick. And so it was 1.5 inches thick. The first part's going to be milling it down to 1 3/8. The second part is the 1/4 inch end mill doing the rough cut. Now I could have went with a 1/2 inch end mill, a 3/4 inch end mill, a much bigger end mill, because on the rough cut to clear that out, because it's 5.5 inches wide, I had plenty of room. But I went with a 1/4 inch bit, and the ball nose, because there's no detail in it. It's just a cove, just a curve, it's a 1/4 inch ball nose running that cut and everything. So if we go look at that piece here and everything, the rough cut is going to just come in and stair step, hog away all that waste material. And again, I could reduce runtime drastically on that by using a larger bit, 1/2 inch, or whatever the case may be. Hold on a second. My simulation's turned off, so you can't see the cut. So give it just a second. It'll show it here in just a second. So it'll stair step that cut, that's going to be the rough. And then, like I said, because it's just a simple cove and everything, the finish cut is going to be just a 1/4 inch ball, stepping over 8%. And it's just going to, back and forth, stepping over 8% to get a nice, clean, smooth step over, 8% the diameter of that bit. And so it's a 1/4 inch bit. Now, again, had I owned one or something, I could have went with a 1/2 inch ball or something like that. But a 1/4 inch gets the job done and all that stuff. But that's the cove. Now, from here, once that's cut, then this piece is milled in half, right down the middle. And I'm only using 1/2 for the 4 pieces of the little box. That's gonna get milled right down the middle, cut, split in half. That's gonna be one box. That would be another over here, and so it goes over, and I'll take it over. My miter saw is acting up on me, so I got to use my table saw with the blade tilted, to do the miter cuts on this, and but that's going to be the 4 sides of the box. So I'm using just a 1/4 inch end mill and a 1/4 inch ball nose. 1/4 inch ball nose. That's the 2 bits that I'm using on that. All right. Let's see here. That is it on the questions so far. The box, this right here, it's a very simple project to kind of put together or to carve and everything. The one piece, this piece right here, is 18 inches long, 5.5 inches wide, and 1 3/8 thick. I ended up gluing 2 3/4 inch boards to face glue them together. Now, what I'm curious about, and I've never really ever had any kind of problem with like a glue line exposure and everything, and seeing the glue line and stuff, because the center is going to be milled away below the glue line of those 2 faces, and really on the sides, just on the upper part of the curves at the middle of the board is just where that glue line would be, and it's gonna just blend right into the grain, if you will, so you won't see any kind of glue line and everything. And I'm always worried about that. Like if my cove would have been right at the glue line, or something, then it could be like I'd be just exposing like a big old, yellowish tint of wood or something. They could, I don't know, be sanded eventually. But long story short, this cove is going below the glue line and everything. So I was able to glue up 2 3/4 inch boards, but the piece only needs to be 1 3/8 inches. So I'll be doing a full pocket cut, and I'm using 2-sided tape to hold it down, the CA glue and painter's tape method to hold it down. The whole top gets pocketed first, an eighth of an inch gets milled off the entire top to bring it from 1.5 inches to 1 3/8 inches, and then rough cut, ball nose cut. And so the next question here, Kurt, is if I wanted to only cut the sides of the curve, how would you use the zero plane to stop the cut? So in the situation now, there's this is not a 2-sided job. And the there's no like zero plane for like splitting in half. This is a 1-sided job. But if I add a zero plane in, let me show you here. Let's tilt it to the what's going to be the best view? Front, left view? Let's do left right here. All right, so if I come up to the model, create a component, add a zero plane. Right now, a zero plane is exactly that. It's a plane that has no surface height to it whatsoever. So here is the zero plane, and this isn't a model. This is not a model. This is a molding cut. Okay, so on here, I don't know if I can combine the two because it's a swept model. It's not really a zero plane, but let me see here. If I give the zero plane some height, 0.5, you're not going to see it in this particular cut. Bear with me a second. Because it's here, it's a model, right? So let me draw the model versus a molding toolpath. I did it as a molding toolpath so people that didn't have a spire could do the cut, because I can't combine, the two. So here is the surfacing toolpath, and the zero plane doesn't interact with it. But if I had it set up as a model, so bear with me 1 second. The model is 1 3/8 inches tall, 1.375. It is 5.5 inches wide, 5.5. Okay, that's that little box right there. 1/8 of an inch. Oops, 1/8 of an inch over. Let's clear out all guidelines from the old project. So from here, missed the whole mark. Let's try that again. There we go. From there, we're going to create a relative guide, 1/8 of an inch over, 0.125 on that end. That's a lie. Absolutely the wrong direction. Delete that and delete that. The guideline needs to be my horizontal guide here, not vertical. Horizontal guide. Let's try that again. Relative guide 1/8 of an inch down because I'm going down. So negative 0.125. Create the guide. And then on this end, it's a positive number because it's going up. So positive 0.125. Okay. I'm an idiot. I'm drawing an end view, not a damn top view. Hold on a second. I'm drawing an end view. So I was right the first time. Goofball. Myself, I'm a goofball. All right, so create that 1/8 inch. I was like, that's not right. Create this 1/8 inch. Now this is going left, so it's a negative number. Negative number. And minus. Okay. Now from here, I'm going to go into node editing, and I'm going to insert a point on that line there. So click on this and right click and insert point. Zoom, 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 kind of get up close and personal with it. Insert a point. Missed that one entirely, so I'll drag it over where it belongs. Let me make sure I didn't miss this one entirely. Oh, missed that one too. Man, my aim is off tonight. Come on now. Okay. So between those 2 points, this is an arc. And the arc goes down 1 inch from its, its position. So the before I move that arc, let me get a guideline to help me out here. I'm going to come up 3/8 of an inch because it's an 1 3/8 board, and that arc goes down 1 inch. So I'm going to come up 3/8 of an inch, 0.375, relative 0.375. Let's try that again. There we go. All right, so this arc in node editing gets pulled down to there. All right. And so now when we create a model, when we create a 2-rail sweep or anything like that, the bottom span doesn't get used. So we delete that out of there. Okay, so we just have that span. All right, let's come over here and let's get out of node editing. Let's bring that down here. Now, my board is 5.5, and this one is all kinds of wrong. What did I draw? That's right, but it's wrong because I'm drawing an end view. My board is only 1.375, and the width is only 5.5, 5.5. There we go. Much big difference from that to that. So the yes, I would love that. Thank you so much. Look at there, guy. I got somebody bringing me something to drink. Good. I was wondering why that part looked so big. All right, compared to my board. One more time, very quickly. Guideline. Bring it over, snap it to the corner, right click on it, and insert a parallel guide 1/8 of an inch to the right. So it's a positive number. Take this guideline, I'm going to move it over here, and I'm going to right click and do a parallel guide -1/8 of an inch. Create that. I'm going to zoom in to the guideline here and go into node editing mode and click on my line, and then right click and insert that point. Come over to this one, get on it this time, right click, insert the point. In between here, turn this into an arc. Let's take a guideline at the bottom one more time and bring it up a relative guide 3/8 of an inch, 0.375. That way I can bring this arc down to that line. Wonderful. And then I can turn off those guides and delete that span. Now that looks more appropriately sized for my board. Let's move that down. Let's get it over here. Now, on this, to make it a component, I need 2 drive rails. So a line across the top here from here to here, space bar, and at the bottom from here to here. Missed my whole line altogether. Hold on a second, undo that. From there to there, space bar. All right, on those 2 lines, that's my drive rail. So 2 rail sweep. Wow, man, I'm like missing the mark. Let me get my line to the right size, folks. Boom. Okay. All right, one more time. 2 rail sweep. Select the top one, the bottom one. That's my drive rails. Select my profile. And I want to sweep it between the 2 spans. Now, if I sweep this like this and everything, the just because my profile is sitting upright like this and not turned sideways or anything like that, it's still gonna, sweep proper. Okay. Now, let's say that I didn't want to carve the bottom of that and I just wanted to carve the sides of this. Then I could come in and set the 0 plane. Whoa. Let me see if it's still in there. Yeah, it is. And on the 0 plane, notice how fat. I was wondering, like, wow, you see how fat that is? Because my 0 plane is set to add, and it's a 1/2 inch, so it added a 1/2 inch to that, right? So I need to merge it in. And let's say that I want, if this is 3/8 down here and I go a 1/2 inch thick, I'm only trimming off a little bit. I want to go up. Let's see here. Let's go up. Let's go up. Let's make this 0 plane 1 inch thick. Let's make it 7/8 inch thick. And we want to merge that part. Oh, that's 875. Let's try 0.875. We want to merge that part. And then we also want to merge the component with it. So merge. Okay. And then you can see how it's kind of created that flat plane there. So it's only going to do the sides. Now, let's say that I just wanted to carve the sides, and maybe that's, the 0 plane. Let's go down a little bit lower. Let's lower that down. And I can use this right here. Let's bring that down a little bit, right? So I can adjust that 0 plane. Let's say I want to, like a skate pike, or not. Is it a skate pike? Skate pike, half pike, full pike, whatever. But skateboard ramp. Okay. So you can adjust that 0 plane and everything. And then now, if I wanted to carve just the sides and not the middle for whatever reason, I can create a rectangle border, like only carve, within the rectangle. So here, let's say I did a pocket cut. Let's set this up as a, it's a 3D cut, but let's say that, I only want to carve. I'll create a boundary line. Let's say that I wanted the bit to only carve in this area. I'll mirror that to the other side, right? And so I just want to carve the 2 sides and not the middle. And the middle, I could create a rectangle down the middle because it's going to be flat. And I could do a pocket cut on that vector, a 2D pocket cut, which would be much faster. Pocket cut down to the 3/8 of an inch deep, because, or 1 inch deep, sorry. From the 0 down to 1 inch, carve that flat and everything, or whatever it is. It's not 1 inch at that point. Let me see what it is in the 3D model. It is, from the top of my board, which is 1 3/8, down to this flat plane, which is 5/8. 1 3/8 minus 5/8. I'll do it over here. 1.375 minus 0.625 equals, so 3/4 of an inch. So I would have a pocket cut on that middle vector with a pocket cut 3/4 of an inch deep. And then on these two vectors, I would do the 3D model cut. So let me show you how that would look in actual real world. Pocket cut, middle here, cutting 0.75 inches deep. We'll use a 1/4 inch end mill. Calculate, preview the visible toolpath. Let's turn off the draw tool to make it just a little bit faster. I should have turned off the animate preview to make it even faster. Yeah, let's let me hit stop on that real quick. Turn off animate preview. Let me turn down the simulation quality. Oh yeah. Much faster. There we go. All right, so that pocket cut removes that material, right? Now I can come in and create the 3D finish, rough and finish cuts on just these two areas here, not the middle area. So in this case, I'll just do a 3D finish. We'll use the 1/4 inch ball nose and calculate. If I didn't do something with the middle, it would stay. If I just carved the sides, the middle would stay at its full 1 3/8, and it'd be kind of like, you know, here. All right. I had evidently all three vectors selected. Let me see here. Is that true? No. But I need the selected vectors as the boundary. There we go. All right. Let that calculate while I answer Kurt's next question. So now you can see the tool pass only carving those two sides. So can you use a zero height plane and move it to above the bottom of the cove? Yeah, that's what I just did. So the zero plane has to have, you give it height. So this is the zero plane right here. If I turn off the model, or if I turn off the zero plane, let's close this. That's the cove. If I turn the zero plane on, that's the surface of the zero plane right there. And a zero plane is that. It's a plane that has zero height to it. Now, this has to have, in our case, the zero plane has to have 5/8 of an inch of height to get to that level. You know, I have to raise it up. I have to get the zero plane up to a certain height. So it's no longer zero. There's height to it now. Zero is down here at the bottom of the board. You know, so if I set this to 0, then the zero plane is down here. And if I turn off the model, that's my zero plane, that little flat sheet right there. So in order to get above the cove, which this is 3/8 right here at the cove, I have to at least be above 3/8. So the surface has to be at least above 3/8 to raise up. Now the rest of you're only seeing the part that's exposed here. The rest of it is inside the model. If I turn off the component, that's the zero plane. This is the zero plane here. So now it has a 1/2 inch height to it. Because 0 is 0. 0 is nothing. To get up above the cove, I got to get up. The bottom of the cove is at 3/8 of an inch high. So I got to get up above it. And so whatever that is, you know, and in my case, I went up a 1/2 inch. So now you're seeing the zero plane. The surface of the zero plane is at a 1/2 inch high. Okay, that's a 1/2 inch. And on the zero plane, on the let me close this tool. Bear with me just a second. It's still hidden. Bear with me. I got to get my properties box to pop up. Stand by a second. Hold on a second. I've lost my I'm glitching out here. I lost my properties box. See on this one. Yeah, I lost my properties box. Well, the there we go. Dog, don't ask me, but anyhow, so here, this is the zero plane right here that I'm moving, so I can change the height to be whatever it was. Man, I don't know. I had to go into the 2D view and change something. I'm not sure what I had to change, but the zero plane can be adjusted up or down, but when it's zero, it's zero. There's nothing to it, you know? So hopefully that answers your question. Let me see here. The only way to move the zero plane is to actually give it height, almost like giving it a base height, correct? Yes. And you're just giving it height, you know, and it's a base height in a sense. But yes, you're giving it height. A zero plane is a flat plane with no height. But if you need it to be up at a certain level, then you have to give it a height. You have to give it a height and everything, so it can be at that. So it can be at that level. And in the world of a two-sided job, when there's actually two sides and all, you have two planes, zero plane, and then the overcut distance or limit plane is referred to as, which is the overcut. How far past the zero plane can I get to cut that bottom part, you know, kind of thing. All right. Yeah, no problem. But yes, you absolutely have to give it height, right? And then if you just want to cordon off, you know, where I'm only carving the left side or the right side or both sides, and then letting my pocket cut do the flat area in the middle, that zero plane surface, there's no sense in your 3D ball nose having to run all that surface if it's flat, if it's not, you know, if it's not a true cove, if it's flattened off because the zero plane is flat. But if I'm only carving a curve to the two sides and it's flattening out, then I'm going to do that center part as a pocket cut. It's faster. pocket cut down to whatever height it needs to be. And then I'm going to have my 2 boundaries that for the finish cut that are going to, carve just those sides that I indicate, right? Depending on how big my rectangles are and all that stuff. Oops. And so, whatever I indicate and everything, on that and all. So it depends on how wide I draw my rectangles here, those boundaries, right? And it's important that if you notice here, the rectangle that I drew, imagine it in 3D space here, the rectangle that I drew saying, hey, only carve in this area, it was bigger, so it's out here. And so you see the toolpath is going below the 0 plane right there. It's cutting right below it because I told it to carve within that area. So I need to make sure if I do create a boundary that my boundary is only wide enough that it reaches, this level here at the, at the 0 plane. If the 0 plane is active, it's getting carved, and you can see where it gets flattened out right here. You see the flatness? That's where the 0 plane is right there. It's hard to tell but you see that, see where it flattens out? That's where the 0 plane was, right? So it flattens out to that 0 plane right straight across, but it has to be active. The 0 plane has to be in there. And it's such an optical delusion that way, but yeah, they don't match up. All right. So I was just using the sides, for example, to talk about 0 plane. Right, there you go. All right. Well, ladies and gentlemen, we're an hour and a half in. There's only a couple of us hanging out here. Any last minute questions, and we're going to call it a night. And I need y'all to let me know either email or Facebook group, the private group, exclusive group, or tomorrow night when we're in the live class tomorrow night. If you're hanging out with me, give me a shout and say, hey, yeah, Sunday will work, or hey, let's do it Monday or Tuesday or whatever. I'm thinking Sunday afternoon. I'll put out, an announcement and all that stuff, but for that little box, or we will just do it like at the beginning of this coming week, just to talk about the jig and things like that. So we'll give it another, 4 or 5 minutes, and then we'll call it for the night. So if you have any questions, now's the time. Now is the time. And also, Kurt, a 0 plane can only work with a model. Do it in class next week. All right. The 0 plane can only work with a model, not a 2-rail sweep. Even though that's technically a model cut, it's still it's not a component. So a 0 plane can only combine with other components to make the composite model. You know what I mean? Hopefully you know what I mean. That's what I'm referring to. Yeah, so we might do it next week's class too. That's a good idea as well. But this weekend, I'm hoping tomorrow, tomorrow Saturday is R&D. So we got the body designed, the springs, the buttons, for the tool height setter. Now that the design is done and we got a couple of prototypes printed, get to hook them up to the CNC and test them. See how repeatable and accurate they are, and how well the spring, tension is, and all of that good stuff. Love it. I love R&D. It's fun. All right. The only the only other news that I have while I have Vectric open here, I want to show you something that I've been working on. And it's in the gadgets. And so in gadgets, you'll see a gadget here called Rotary Calculator, right? Rotary. I'm working on a rotary calculator. Now, right now, on the Rotary gadget, my graph at the bottom is printing horizontally or vertically when it should be printing horizontally. So you're going to see some color lines going down at the bottom here. When I calculate this, they're supposed to be going horizontal. So I got to go into the code and swap the direction. But this calculator will allow you to set up your CNC or put your model in. And if you're using a gearbox or a pulley ratio for your your rotary axis, this is a rotary calculator. Could also be used as just a speed and feed calculator kind of thing. But you can apply your machine's motor settings, the microstepping and the steps, but also you can apply the maximum feed rate of your machine, and it will calculate the feeds and speeds, but it'll cap them if they exceed your machine's max feed rate capability. It'll cap it at that. But there's a variety of materials that I'm working with right now, and things, different bits and all. Bit sizes and number of flutes, and then the calculating the plunge rate for most chip feed and on chip load charts and stuff like that. Typically, your plunge rate is half the feed rate, or it could be less. So 0.4 of your feed rate, 0.4 or 0.5 is 50%, 0.4 is 40%, that kind of thing. So what percentage of your feed rate do you want to be your plunge rate kind of thing? If you leave it blank, it'll automatically calculate it based off of the material that you're cutting in the feed chart. But in my case, I like to be at 0.5, 50% of the feed rate. And my rotary stock diameter, let's say my diameter was 3 inches. That's the only two things I really need to fill in here. If I wanted to override the RPMs and give a specific RPM, I could. If I wanted to override the inches per minute, like what I would like to achieve, I could put that in. If I leave them blank, it's going to automatically calculate the speeds and feeds and everything based off of, the tools that I'm using and the material that I'm cutting in. But when I compute this, it'll compute the chip load that was used, but it'll compute the raw feed rate, which is your feed rate, but it also computes the capped feed rate. So this feed rate doesn't exceed my 250 inch a minute, capability. So it stays at 207. The RPMs are 18,000. The plunge rate is half the feed rate, so 103.5. The circumference of my 3-inch diameter stock is there, but then the motor settings for your rotary axis, your degrees per minute, the A-axis steps per second, the speed and the rotation of the motor. So all those settings go in that you could plug into your machine or to your software for that particular setup. Now, on the chart that shows kind of like your raw feed rate calculation versus your capped calculation, what the difference was, and also your A-axis rotation versus the motor's limit, of settings. There's a graph chart here that would show kind of that ratio, that chart and all. Well, when you update the chart, my lines are going vertical. They're supposed to go horizontal. So I gotta change that in the code and everything. But this calculator, this gadget, is doing exactly what I want it to do. It's achieving exactly what I want for rotary calculations. This comes in very useful when I'm changing from a regular inch per minute feed rate for rotary carves to what's called inverse time mode, where it says, hey, complete this task in 0.5 seconds. So it makes the tip of the bit and the rotation of this tool kind of be nice and smooth. So as that's turning, that bit is moving, and it's kind of a nice smooth movement, and it achieves that particular cut or that particular segment or whatever in that time frame allotted. And so it's when your controller gets put into G93 inverse time mode versus G94 inch per minute. In inverse time mode, it sets it by time. So your let's say 200 or what am I at 207 inches per minute. That 207 inches per minute is it's now, instead of an inch per minute, it's a time. So in 207 seconds or whatever, milliseconds or whatever it is, there's a calculation, and it's pretty in-depth calculation, but we could talk more about inverse feed rate if we ever do a rotary class and all, but it sets that time. So if we were to look at a sample G code, file open, downloads, inverse time, and you would see here on the feed rate where it says 10,416.6. That's not inches per minute. Technically it is, but it's in milliseconds, whatever. It's like it's saying, hey, complete that one segment, this one move in this many seconds, from here to there. And so every line gets an F code for inverse time mode. And it makes sure that the rotation and the tip of the bit are a nice smooth movement. There's no jitteriness or any of that. Long story short, it's pretty entailed, but one day we're going to have a class on it. And in the process of anticipation of that class, I wanted to build a step calculator. And so I decided to do it in as a gadget. And if we look at the gadget code, so this is the code this is the Lua code for that gadget. And, all of the calculations and everything to get those degrees per minutes, and the steps per degree and all of that. So all those calculations, and then the HTML to create the layout. I got to go down in the HTML and I got to change my feed bar. They're going the wrong direction. I need them to be horizontal, not vertical. And then there's different models, like, you can add your model to your machine to the list. I got all the digital woodcarver models in here. Materials, just a general list of materials, but in the Chipload chart, it has all the softwoods. It has all the hardwoods, so the category, the family, these are all hardwoods. So the family of hardwoods is just under under hardwood, and it has the different router bits and the different flutes and everything. And for that particular bit, what the minimum and maximum chip load is for that router bit and things. And yeah, so all those three things, those three tables go with that. So when it calculates, it reads from those, did I choose hardwood? Did I choose softwood? Did I choose PVC? Did I choose acrylic, aluminum? And what bit did I choose and what diameter I choose? It looks all that up and it puts in the, it does the calculation based off the minimum and maximum, the average chip load, for that bit. So a long story short, that's all the technical stuff. But we had talked about, we had a discussion on building, gadgets and everything. And so this is kind of a gadget here. So when I apply the model, I can look and see what model I've applied. I can ping it. I can run a diagnostic on it to see what model I have and then what bit settings I chose. And then I can do a self-check in the software to make sure it's reading from all those three files, properly. And it found the match with the proper, and everything. So it's just kind of a diagnosis button in case something, crashes or something like that. Yeah, man, cool stuff. I started out, just so you know, if we open it, I started out with a spreadsheet first. So it all evolved. So once let's not my calendar. Heck of it, Laney. I didn't want my calendar. I wanted my Google Drive. It started out with a spreadsheet first. And on the spreadsheet, the list, the list of materials and bits and diameters and flutes, the machine models and the motor settings, for the rotary axis and everything, the micro stepping of the motors and the gear ratio and stuff. So all those that got put in, and then the chip load table, the different types of hardwoods and what their chip load and everything are, and everything, based on the whatever, diameter of bit. So it started there, and then the calculator, that you choose your material, you choose your type of bit, you put in the diameter that you want, the number of flutes, and then it automatically, as you're filling this in, it automatically fills in and calculates all of these things. And that was cool, but not everybody has Excel, not everybody has Google Sheets and everything. So after I had all the functioning formulas, right? All the functioning formulas. Then it was a matter of putting them as a gadget, So, yeah, fun stuff. That's what I do in my spare time when I have spare time. Okay, let's see here. How do you set a tapered juice groove on a cutting board? So, first of all, no need to, you set the cut height, but you're going to be using a box core bit. So, depending on what size you want your juice groove, let's go with a 3/8, 0.375 core. I said box core, but it's core box bit. Core. Let me learn how to type here. 0.375 core box bit. Okay. And whatever brand you're into, go for it. But a core box bit. It's that nice half marble shape and everything. And once you have your bit, let's say that let's say my cutting board was a 12 by 16 or what have you. And let's say on my juice groove, I want the juice groove to be inset, offset, inward, let's say a 1/2 inch in from the walls, right? Whatever the case may be, whatever you want. And so that profile, you're going to do a profile toolpath, however deep you want your juice groove to be. Let's go just 1/4 inch for right now, but then you choose your core box bit. So I'll use a 3/8 inch core box bit. And we're going to be cutting on the line, and you calculate that toolpath, and you create that juice groove. Okay. Now, if you want, using the word tapered, if you want your groove or something to start at 0 and then taper down into this, then that's a fluting toolpath. But otherwise, most juice grooves are even all the way around, the same depth all the way around. But if you want it to taper from 0 down to a depth and then come around to that depth, then on your rectangle, you have a start point and a finish point. So let's say that the start point and finish point end here. Let's go to node editing and let's cut the vector there. And you would use a fluting toolpath, cutting, let's say 1/4 inch deep, but with that box core bit, core box bit, 3/8 inch core box bit. And I want to ramp over the entire length, or you can have it start and ramp down to that 3/8 or that 1/4 inch deep over a certain distance and then come around. So I don't want it to ramp over the entire length because it's going to take the entire length to get down to the 3/8. I want it just to kind of go from 0 down like a ramp, but I want it to kind of be short. So I would want to start there. And then on the ramp percentage, I want the ramp to say, let's say I want it to be 10% of the line. And I want it to be a smooth transition when I compute that. So if I wanted that for whatever reason, it would taper down and it went this way across here. But from 0, it would taper down and around, and then it would be at that 3/8 of an inch all the way around. But it would be 0 where it started. If you wanted it to taper back up to 0 where it met in the corner, you can have your juice groove not go to the corner. They don't have to meet there. You can stop it here and here if you wanted to. I've never really seen that, but it's a thing. But you can have it ramp here. So at the first 10% and the last 10% of that line, it tapers, down and down to that 3/8. But mostly it's just an even cut all the way around. Draw your rectangle, use your core box bit, profile cut down to the depth that you want, and that's your juice groove. Okay. Very rarely would I see it taper down into a cut, but that was the wording that you used, so I thought that's what we would try. All right. Let's see here. Shallow on the top center and a gradual taper. So the top center, we change instead of the corner here being the cut vector in the middle, you would cut the vector there, and same thing. And so let's say instead of 10%, let's go 25%. Reset the preview. So what's going to happen is it's going to taper down, cut, and then taper down back to 0. So if we preview that, it would look something like that. Now, if I wanted to have the taper widen up to 0, and maybe I wanted a gap right here, then I would come over here, and in node editing, I would move, this over here, I'd make it even, right? Whatever that distance is, kind of thing. And I would recalculate that, reset the preview the visible toolpath, and to where, it's flat here, and then it tapers. And I'm only going 25%. So you could go longer and the taper would be wider coming around here, but whatever you want it to be. But it's a fluting toolpath if you're going to do that. If you're doing just a juice groove all the way around, which is the norm, then it's a fluting toolpath. But if it's a juice groove all the way around, it's a profile toolpath, right? Now, if you want your actual cutting board to taper down, like at the bottom part of the cutting board, you want the cutting board to be flat, and then it want to, come at a ramp down to the juice groove or something, then that is, you could set it up as a fluting toolpath with multiple lines, multiple passes, or it could be a 3D model cut where, it's drawn in, whatever the situation is. Shallow in the top and the center, and gradually tapering around the top, down the sides, and then the deepest at the center bottom. So again, I don't on that taper, instead of 25%, you could go 80%. So the taper gradually goes 80% of the cut, and then it's at its deepest part at the bottom, kind of thing, or whatever. So 50%. So I think this would be 50% here. So let's go 50% of the line. Reset the preview that toolpath. So it would slowly, from 0, it would taper down. And by the time it reached the bottom, it would be at its deepest cut. And then it would slowly taper back up to nothing. It's a fluting toolpath. All right. And then when you use it on 1-inch thick material, a two-sided job, and give the plane, give me just a second here. When you use it on 1-inch thick material, 1-inch thick, a two-sided job, and give the plane a 1/4 inch height, the plane will be a 1/4 inch from the top and 3/4 inches from the bottom, right? So you have 0 planes on, technically kind of on both sides. So to answer your question, yeah, in a sense. So if I set the job up as a two-sided job, and I take, let's build it up to a 1/2 inch on side 1. Copy that to the other side. Okay, so we have a 1-inch board. Top half is 1/2 inch, bottom half is a 1/2 inch kind of thing. When we add a 0 plane, and we give that 0 plane, you can see the outline there, but we'll give the 0 plane a 1/4 inch height, and on a flat surface, I mean, it is what it is, but the let me turn this off real quick. So give me just a second. If I set a 0 plane here, let me turn that off, and let me flip this back on. The 0 plane is at the 1/4 inch here and 3/4 inch there, just like you said, Kurt. So when you gave it that height, it's only on side 1 here. It's a 1/4 inch from here, and then the 3/4 from here from that other side. I don't know if you can see the dotted line. It's really faint to see. I wonder if there's a better view. Okay, there you go. So you see it's here, and then from the bottom, it's there, 3/4 and then a 1/4. So just like what you said in your question. Yes. Booz has this method to drain into a dish with a hole in the board for the dish under. Yes. So let's see here. Cutting board with drainage. And in some situations, the where it drains into, and it tapers down, if the juice runs into the groove, it's kind of ramping down to, so it's a drain, it's angled and everything. And so you would do that fluting, like I just said, you know, a 50% where it starts and it's 50%. So it's at its deepest end at the halfway mark. And then 50% it starts going back up to 0 and everything, you know, kind of deal. In that, you know, there's lots of different styles. I just happened to, you know, this is John Booz and Company. And I believe that's who you were referring to when you said Booz. But you know, it has that taper and everything. Yep. Oh, okay. That's the actual board. That's good. See there? How psychic I am. But yeah, it's that's that fluting toolpath, you know, that gradual ramp. All right, ladies and gentlemen. So any other questions? We're 2 hours in. We had a couple of people, you know, engaging a little bit more. Cool. So Kevin, good to see you. But any other last questions before we call it a night? And then we'll work out in the shop in our next class on the CNC. We'll do that deco box. Kevin, I don't know if you were here for the whole class or not, but we have the deco box. I'm going to be talking about the parts and the jig and everything that holds some of the parts for the cuts and everything, and we're going to do that in a different class. It was going to be tonight, but old DWC customers had me rocking and rolling today, so I didn't get a chance. I got some of the parts cut, but I didn't get everything done, and all. But yes, fluting toolpath is this toolpath right over here. Fluting right there, and on that toolpath, you can ramp over the entire length. Now, that's not the right choice for you. Ramp over the entire length means that at the start of the line, it's going to slowly ramp to the depth that you specify in that flute depth. It's going to slowly ramp down, and by the time it reaches the end of the line, it'll be at that depth. Okay, that's not what you want. You need it to ramp down and then get to its depth at a certain, you know, part, but, you know, be at its fullest depth at a certain part, and then, but coming up the sides, you kind of want it to ramp back up. So the option then in that case would be not a ramp at start, but a ramp at start and end. And you can set a length, how long you want it to run before it ramps down to the final depth, or you can set a percentage. In this case, I set 50%, meaning that from the start, by the time I got 50% of the line, it was already its full depth. And then it started coming back up to 0, you know, on that other half, the other half, right? So that's that. And then a smooth transition. Now, if you went linear, it'd be just kind of a, you know, straight down. You want it to kind of smoothly go into that depth, most likely, but you can try linear as well too. If we calculated a linear, it's let me turn it to the side so you can see the actual blue lines. But from 0, see if I can zoom here, you know, it when it comes around here, it's just a straight ramp down, you know, versus a smooth ramp, which kind of gradually, you know, right here, it's more of a gradual, it's not so harsh, it's more of a gradual cut around that corner and everything to there. I would say smooth would be the way to go, but it's totally up to, you know, give both a try or whatever. There may not be any difference really as well either, but there's a slight difference, not much. All right. Cool. All right, everybody. Well, we are going to call it, and then we'll reconvene next week, and we'll get out in the shop. And if I'm out in the shop and I'll film the cove cut and stuff, and I can always share those little videos with you in the Digital Woodcarver, I got Digital Woodcarver on the brain, in the Spindle TV exclusive group on Facebook, in the chat area, on YouTube, in the community. I can share links to that kind of stuff and everything. So if I do release any kind of video and all. All right. Tomorrow, I don't know what tomorrow night's class is, but there is a class tomorrow night it's a public. We'll see everybody if you want to pop in. It should be interesting, and then we'll go from there. I'm looking forward to my weekend because I get to do some R&D on that part, that tool height setter. Fun stuff. Get to test it out, see how it's going to work. We just got it printed and put together, so we're getting to see how it works now. All right, everybody. We'll catch you later. And thank you for the questions. Thanks for participating. And as always, thank you for